Greetings. Topic of research is information extreme machine learning of an onboard ground object recognition system with a choice of base recognition class. Topic deals with ground object recognition system of unmanned aerial vehicles. Nowadays, large number of human activities require up-to-date information of terrain. It includes object recognition, object tracking, and recognition of abnormal states of objects. Main way to solve this problem is to use the ideas and methods of machine learning and pattern recognition. But known methods of data mining, including artificial neural networks, have a number of disadvantages that are manifested in the processing of large amount of data under arbitrary conditions of the formation of images of terrestrial objects. Therefore, the creation of a method of machine learning system invariant to multidimensionality of space, of feature space, and flexible to relearn through expansion of the alphabet of recognition classes is an urgent task. So, the purpose of research was to increase the functional efficiency of the onboard system of unmanned aerial vehicle for autonomous recognition of terrestrial, natural, and infrastructural objects on the basis of machine learning. To accomplish the purpose, it was necessary to solve following tasks: to design a categorical model of information extreme machine learning, to develop its algorithm, build decision rules within the geometric approach, programmatically implement machine learning algorithm for given alphabet of classes, and then evaluate functional effectiveness of machine learning in the operation of onboard recognition system in exam mode. The formulation of problem of information synthesis of onboard recognition system is reduced to search for the maximum value of average in alphabetical order of classes information criterion for optimizing the parameters of machine learning. Images of terrain are considered as an input dataset for recognition class alphabet of discrete number of classes. Using geometrical representation of data, we got parameters of recognition class containers. In process of machine learning, there is need to perform optimization of container radii and tolerance system boundaries. Information synthesis of system proceeds with finding the global maximum of the average value of the information criterion. This slide shows the information criterion that was used in the work to optimize machine learning parameters. It's based on modified Kullback measures, and it's a logarithmic criterion to evaluate entropy of system. Also, it's based on hypothesis of equally probable events, statistical reliability, and error values. The iterative algorithm of onboard recognition system machine learning is shown below. Optimization of system control tolerances for recognition features deals with the delta parameter, which is equal to half of the symmetric tolerance field. Hence, idea of information extreme machine learning is to find global maximum value of information criterion in the area of possible values. Here we may see decision rules built according to the optimal geometric parameters obtained in the process of machine learning, according to which the vector of features on the exam belongs to recognition class, which has maximum possible membership value. Because decision rules are based on geometrical approach, they, unlike artificial neural networks, are characterized by high recognition efficiency, which is extremely important on onboard recognition systems because identification on the board of drone will take place in real time. aerial photographs were used to perform input to form the input mathematical description of onboard recognition system. On this slide, we may see the input image of an alphabet of classes. Among these classes, we are mostly interested in objects of man-made origin, like first class, the road. The obligatory state of training within framework is the optimization of system control tolerances. In this case, the task of choosing the base class may be considered. The assumption was made and experimentally confirmed that it is expedient to choose the class with the largest variance for the place, because due to its variety of features, it will be closest neighbor to any other class in the alphabet. According to the concept of framework, the obligatory procedure of machine learning is the optimization of system of control tolerances for recognition features, which plays the role of the level quantization into the transformation of training matrix into a working binary matrix. The class that has largest variance of learning matrix is expedient to make basic class for our system. This slide shows us a graph of the dependence of recognized classes, recognized recognition classes of the normalized information criterion and delta parameter, which changes simultaneously for all features. In addition, a sequential optimization was performed. Here, delta varied separately for each feature to optimize parameters once again. Here we may see graphs of dependencies of normalized information criterion on the radii of the containers of each recognition class. According to that results, decision rules were built. The image obtained as a result of identification of the frames of region can be considered highly reliable. It should be noted that man-made objects are classified classified almost without errors, despite arbitrary position on the image. Making conclusions, during the research was developed an on-board ground recognition system, which is integral part of modern unmanned aerial vehicle system. At the same time, hypothesis of choosing the base class by variance was put forward and experimentally confirmed. This approach has allowed with minimal time to increase the functional efficiency of the recognition system. The result of research were implemented in the research center of missile troops and artillery of armed forces of Ukraine, and were used in the implementation of the state budget team at the Department of Computer Science of Sumy State University. Here you may see information about authors of research. If you have any questions about this topic, about this research, you may contact us for getting answers. Thank you for your attention.